degrees, you have to rotate around, okay? So 750 degrees, that's positive, so we're going counterclockwise. If we go around 360, if we go 360 again, how much is that? 720. And so we're going like another 30 degrees to get to our 750. That was the first quadrant. What about negative 680? Which quadrant? It's the first quadrant. Okay, negative 680. Let me sketch that one. All right, if it's negative, what direction are we going? Clockwise. So negative 680, guys, shh. Negative 680, we're going this direction, so that's negative 360. If we go again, negative 360, what's that put us? 720, which is a little bit too far. If we went back 40 degrees, we'd be here in the first quadrant at negative 680. Do you guys remember your quadrants? Okay. Before we start the new stuff for today, let's talk about what we did Friday. Okay? Shh. We discussed our quadrants on Friday. We discussed angles being in standard position. Now, if an angle's in standard position, where is the initial side? On the positive x-axis. Remember? We said, let me get a new page here. We said standard position is only true if the initial side is on the positive x-axis. What's the other side called? The terminal side. Which side moves? The terminal side. Which way does the terminal side move if the angle is positive? Counterclockwise. And if the angle is negative? Clockwise. Okay. The two papers you picked up today, one of them was a blank unit circle. Put this one to the side. We're going to get to this, but not first. Okay? The other paper you got starts with why is it the unit circle. That's where we're going to begin our notes. Okay? So you are on the that says why is it the unit circle. And you have a diagram that looks like this. And you've got some points. 1, 0, 0, 1, negative 1, 0, 0, negative 1. What do you notice on this diagram? A lot of ones, right? When you guys came into class last week, I told you we're starting with the unit circle and we're going to work our way up to this unit circle and understanding all of the pieces. Well, one of the first pieces I wanted you to understand is why it's called the unit circle. And the whole reason it's called the unit circle is because the radius is based on 1 unit. If I drew in an angle here, no matter where I put that angle, my radius would be 1. That's what makes it the unit circle. Now, for some angles, it makes it easy to find their coordinates. If this was on a coordinate plane and I had a radius of 1, there are certain angles that I could find their coordinates for, such as 0 degrees. What are the coordinates for a 0 degree angle? You're looking at them. 1, 0. Okay? A 0 degree angle, the ray is stopping at the 1, 0 mark on your unit circle. What does the 1 represent? the unit. Your 1 is your x value. The 0 is your y value. Why is the y value 0 there? Didn't go up any. Simple explanation. Why is the x value 1? Because it's over 1 unit. Okay, simple explanations here. Let's talk about a 90-degree angle. Okay, 90 degrees would be up here. That would mean my terminal side looks like this. What are the coordinates for a 90-degree angle? 0, 1. Okay, you should be filling these in on your notes. All right, a 180-degree angle looks like this. The terminal side, that's 180 degrees. What are the coordinates for a 180-degree angle? -1, 0. Basically, because that ray is stretching left 1, up 0. All right, a 270-degree angle. What are the coordinates? 0, -1. Because that ray didn't move left or right, but it stretched down 1 unit. What are the coordinates of a 360-degree angle? 1, 0. We've worked our way back to the start of the circle. We've done a full rotation. So a 0-degree angle and a 360-degree angle have the same coordinates. Are you guys with me so far? Okay. Now these are kind of our basic angles. They're easy to find, and they're easy to find the coordinates because they lie directly on the x-axis or the y-axis. But if we venture away from those basic angles and we move away from the x and the y-axis, it's a little bit harder to find our coordinates. All right, let's talk about 45-degree angle. I'm going to sketch a picture like what you have. So we've got our unit circle. Why is it called the unit circle? I'm going to ask the question like 5 times today. Y'all have got to know this answer. Why is it the unit circle?
Because it's all the same one.
Because the radius is 1 unit. You're basing the circle on a 1 unit radius. Okay, so let's consider a 45-degree angle. This is a positive angle. And I want to talk about its coordinates. Now, are the coordinates... Let's talk about the x-coordinate. Is it going to be greater than 1, less than 1, equal to 1? What do you think?
Greater.
It's going to be less than 1. Okay? Look up there. If I did a little line, okay, and brought it down, is my x greater than 1 or less than 1? Less than 1. Look, right here, that's 1. And we're to the left of that. It's less than 1. What about my y? It's less than 1 also because we're not going up a full unit. If I look at 45 degrees, is the x-coordinate going to be positive or negative?
Positive.
It is going to be positive. Why? Because it's in that first quadrant, basically. Okay? Remember our quadrants? 1, 2, 3, 4. If I'm in the first quadrant, x is going to be positive. What about y? Positive. What about an angle in the second quadrant? What would x be? X would be negative. What about y? positive because it's above the x-axis there. What about the third quadrant? What would my x be? X would be negative. What about the y? It would be negative because you're below your x-axis. What about the fourth quadrant? What would your x values be? Positive, and your y's? Negative. So, let's say 70 degrees. Would a 70-degree angle have a positive or a negative x? Positive. What about 200 degrees? Would 200 have a positive or negative x? Negative. What about 100? Would 100 degrees have a positive or negative y? Positive. Where's 100 degrees? What quadrant? The second, and that would be a positive y. Okay, so I want to think about that with that 45-degree angle. I want to find another angle with the same x-coordinate as my 45 degrees. Another angle with the same x-coordinate. If x is positive, and I want to find another angle with the same x-coordinate, what quadrant is it going to be in? The fourth one. Okay? I'm talking about this 45-degree angle. And I want to find another angle with the same value of x. And I know here that x is positive. Where else can I find a positive x? In the fourth quadrant. What do you think that angle would be in the fourth quadrant that kind of reflects 45 degrees? We could say negative 45 degrees. Very good. If I'm talking about a 45-degree angle, I want to talk about another angle the same size, such as negative 45. Now, the first question on your paper there said, what is another positive angle with the same x-coordinate? So instead of negative 45, what would the positive angle be? I heard it, 315. If I started at the initial side, so I started at 0 and wrapped my way around the circle, that would be 315 degrees. How do we know it's 315? 360 minus 45 would give us 315 degrees. So another angle, positive with the same x-coordinate, would be 315 degrees. What about another angle with the same y-coordinate? What quadrant would that be in? The second, very good. If my y was positive, and I wanted something with the same y value, not quite. We know it's going to be kind of equal in size to 45 degrees. How do I figure out what that angle is? How far past the 90-degree mark is that? It's 45 degrees past the 90-degree mark. What's 90 plus 45? 135 degrees. Okay, so that angle in green, 135 degrees, would have the same y value. Would it have the same x value as my 45-degree angle? No. How would you compare the x value there? It would have a negative x. If 45 degrees, the angle I have in blue there, If 45 degrees is in the first quadrant and it has a positive x and a positive y, and then I reflect it over into the second quadrant, and that's my 135 degree angle. The y is still positive because it's still above the x-axis, but the x is negative. It's been reflected over. Okay? The third question on your notes there, you've already answered this. What's a negative angle with the same x value? That was the negative 45. Negative 45 would have the same x value, but it's a negative angle. What about an angle greater than 360 degrees with the same y value? I want an angle greater than 360 degrees, but I want to have the same y value. I could go around. And I could only go around, I could go around one full time, or I can go around two, or however many. I just said something greater than 360. So let's say we start on our initial side there. I'm using a purple here. And we go all the way around. How far is that? 360. And we keep going to the 45 degree mark. What's 360 plus 45? 405 degrees. Would that have the same y value as 45 degrees? Yeah. Where else could I go to get the same y value? To the second quadrant. So suppose I went all the way around 360 plus 135 more. Where does that put me? 495. 495 degrees would have the same y value. Okay, let's do the same thing. Let's talk about 30 degrees. Some of you have put your heads down already, and I am telling you, you are going to be lost. Okay, so let's talk about a 30 degree angle. And it's got some coordinate x and y. This is still on your note-taking guide there. I want to find another angle that's positive with the same x coordinate. What quadrant do I need to be in to get the same x coordinate? The fourth quadrant, thank you, the fourth quadrant. So let's say we reflect that angle over so that it's still the size of a 30 degree angle. I know that's still going to have the same x value. What could you say about the y value there? It's going to be a negative. Very good. How big is that angle if we're going in the positive direction? Very good. From the initial side, wrapped around to our terminal side, that would be 330 degrees. How do you figure that out? Right. It's not a full revolution, so it's not quite 360. You take off that 30. Okay, your next question there. I want to find an angle with the same y coordinate. So what quadrant do I need to be in to get the same y coordinate? The second. Okay, and I'm basically going to reflect that angle over so that it's still the size of a 30 degree angle. And I know if I do that, the y value will be the same. What will the x value be? A negative. How big is that angle? 150. How did you get that? Okay, That's a good way to do it. What's another way to figure out that this is 150? You could do 180 minus 30. 180 would be halfway around that circle and take off that 30-degree piece. So that's 150. What quadrant do I have to be in to get a negative x value? The third or the second? So to get a negative x value, I've got two options here. I could be in the second quadrant or I could be in the third quadrant. So let's see what it looks like in the third quadrant since we haven't done that one. All right, I know that would give me a negative x. What would it give me for the y? A negative y. How big would that angle be? 210. How do you get 210 there? 180 plus 30. 180 is halfway around your circle plus that 30-degree chunk. All right. What angle would have a negative y value? It's already up there. What angle would give us a negative y? 330 or 210. What quadrants were those? The third and the fourth. So if I said I have this angle in the first quadrant and I want to find something with a negative x, where could you look? Second or the third? If I wanted to find something with a negative y, where could I look? Third or fourth. If I wanted to find something with a positive x, where could I look? First and fourth. What about a positive y? First or the second. Okay, you guys catching on to that? Are you seeing some patterns here? Okay. Excuse me. Are you on the back of your paper already? Okay. So let's talk about that 45 degrees again. Yes. Okay, here's the best part. We're going to look back at a 45-degree angle again. Good thing y'all have perfect circles on your paper. All right, and we know some of these coordinates going around the unit circle. And why do we know these coordinates? For example, how could I find the coordinates for a 90-degree angle? They're there. It's because those angles are going on the x-axis or on the y-axis. So we knew those values exactly. We knew to draw a circle with a radius unit 1, you go left 1, up 1, right 1, down 1. So 0 degrees, 90 degrees, 180, 270, 360. All of those were on the x or the y axis, so you could find them easily. But 45 degrees is not on the x or the y axis. So we need to figure out how to find those coordinates when they're kind of in a free space there. We don't have a grid to go off of. We need to figure out what to find. And I put a hint on there to use special right triangles, and I'm going to show you how here. If I take my ray from the terminal side and I drop down a line and a line here, what would you call that? A right triangle. Okay, that means here's my right angle. And that bottom left angle is 45 degrees. So how big is the top right angle? 45. Okay, that's a special right triangle, a 45, 45, 90-degree triangle. Think back to Math 2. Does anyone remember how to figure out your legs and your hypotenuse?
A squared plus b squared equals
That's the Pythagorean theorem, which works for right triangles. If you knew a side, you're on the right track. You were more on the right track with the square root of 2. Do you guys remember this? Labeling your sides x, x, x square root 2? Okay? That's what you had to remember with your special right triangles. You did a 45, 45, 90 triangle, and you did a 30, 60, 90. I am not going to expect you to regurgitate that stuff from Math 2. Right here, the point is to show you a connection where this is going. Okay? So if I drop down some legs there, and I've got my hypotenuse, which part is the hypotenuse? Alongside the x square root 2. Okay? The hypotenuse of that triangle is the blank of my circle. What? The radius. The hypotenuse of my triangle is the radius of my circle. How big is the radius of a unit circle? 1. So I know the hypotenuse is equal to 1. So I can say x square root 2 equals 1. I'm going to divide by the square root of 2. 1 over the square root of 2 has to be rationalized. Your calculator would do it for you, and you would get x equals the square root of 2 over 2. That's one of our coordinates. We just found what x is. But I still need to know what y is. Where is y in that special right triangle? Is that not the same thing as what? Yes. Very good. Okay. Look up there at the diagram. We've got x on the bottom and x on the side as the leg. Well, that x on the side, that's vertical. That's y. So we looked out. X and y are equal to each other here. So what's the value for y? Square root of 2 over 2. Okay, that's a must. You have to know this. We could do the same thing all over again for a 30, 60, 90 triangle. Okay, I could say okay, let's make sure you guys are getting all your important pieces here. Why is the unit circle the unit circle? Has a radius of 1. How could I find the coordinates for a 45-degree angle? Use the radius as the hypotenuse for a special right triangle. You can repeat the same thing all over again with a 30, 60, 90 triangle. Do I expect you to be able to do your special right triangles anymore? No. Would this be a good bonus question? Yes. Okay? This is the sort of thing I don't expect you to be able to do over and over and over, but if you could show this and demonstrate this, it would be worth extra on something like a test. Okay? I'll go back if you need to. Let's say, okay, here's our circle, and here's my 30 degrees. I'm going to draw in some legs, and I'm going to make a special right 30, 60, 90 triangle. Well, 30, 60, 90, that was 2x, x, and x square root 3. If you did the math, you would find out that your x was equal to 1/2. Or sorry, that your side there was equal to 1/2. Okay, you don't need this piece. I'm just showing you that we could do it all over again with a 30, 60, 90.